Sorry guys, I had a visitor come in and had to deal with a couple of things. Alright, so now let's look at our examples. Alright, let's look at our examples. So it says, consider the following rational expression. 2 times a minus 1 minus 2 over 6 times a minus 1 minus 3a. It says turn to your neighbor. Obviously you can't do that unless you have a neighbor besides you and you have somebody to talk to. It says for what values of a is the expression undefined? Alright, so I can figure out how to figure out this expression cannot be equal to 0. So in order to figure out what I cannot have for x, I would set 6 times a minus 1 minus 3a equal to 0. Okay? Cannot give me 0. Alright, so then let's go ahead and simplify this and figure this out. So I get 3a minus 6 is equal to 0. Then I add my 6, I get 3a is equal to 6. A cannot be 2. Okay? Let's reduce the rational expression with a not equaling 2 in lowest terms. So since there's no common factor visible in the given form of the expression, we first simplify the numerator and the denominator by distributing and combining like terms. Alright, so let's look at this. So I know that x cannot equal 2, or that a cannot equal 2 here. Alright, so we want to reduce it to lowest terms where a cannot equal 2. Alright, so we get 2 times a is 2a, 2 times negative 1 is 2, minus 2. And then 6 times a is 6a, minus 6, minus 3a. Alright? And then we're going to, we get 2a minus 4 over 3a minus 6. Okay? So we have reduced that to lowest terms. Next, we factor the numerator and the denominator and divide both by a common factor. Alright? So, now what we can do is we're going to go back to our original here, and we're going to factor. So we get 2a minus 4 over 3a minus 6, which is what we got up here. Let's factor something out. I'm going to pull that 2 out, so a minus 2. Pull a 3 out, and I get a minus 2. Look, I have a common factor here. So when I divide that common factor, it disappears, and I get 2/3. Okay? So as long as a does not equal 2, we can see that this and 2/3 are equivalent rational expressions. Alright? But if we allow a to take on the value 2, this becomes an undefined expression. However, 2/3 is always defined. Okay? Alright, so let's talk about these. Let's look at these last 4 questions. Reduce the following rational expression to lowest terms and identify the values of the variables that must be excluded to prevent division by 0. Alright, so we are going to look at this, and we will start with reducing it down as low as we can. Okay? So we get 2x plus 2 plus 2 over 2x squared plus 2x plus 3x plus 3 minus 1. Alright, so I end up with 2x plus 4 over 2x squared plus 5x plus 2. Okay? Now, I'm going to see if I can come up with a common factor. I'm going to pull a 2 out of here, and that leaves me with x plus 2. And then I'm going to factor this. So I'd factor at 2x and x. And I'm going to try to get that 2 there. So that would be 2, that would be 1. And they're both positive. Alright, when I reduce those, I end up with, or when I divide those, I end up with 2 over 2x plus 1. Alright, so I can say that 2 over x plus 1 plus 2 over 2x plus 3 times x plus 1 minus 1 and 2 over 2x plus 1 are equivalent as long as x does not equal 2 and x cannot equal negative 1/2. Because those are what I figure out here. Here's where I figure out my x's cannot equal. If x is negative 2, or I'm sorry, if x is 2, no, that's negative 2, that's right, I didn't put a negative there. If x is negative 2, I get 0, and if x is negative 1/2, I get 0. So x cannot be those, so therefore they are equivalent as long as x is not negative 2 and x is not negative 1/2. Alright, let's look at B. Alright, so I'm going to look at this. I'm just going to go ahead and factor my top. So I get x and x, and 3 and 2. And 3 is going to be negative, 2 is going to be positive. And then on the bottom, I'm going to factor out a 5, and I get x squared plus 2. Now, I'm going to pull on x, sorry. So I pull out a 5x, and I get x plus 2 inside. When I divide those, I end up with x minus 3 over 5x. Alright? So I know that x squared minus x minus 6 over 5x squared plus 10x and x minus 3 over 5x are equivalent. Alright, but now I have to make sure that there's nothing that x can't be. Well, x cannot be 0. Alright, because if x is 0, I end up with 0. And x can also not be negative 2. So, and x cannot equal negative 2. Alright, looking at this, I'm going to go ahead. There's nothing I can really do to the top part. So I have 3 minus x. I have the difference of perfect squares. Hopefully you learned how to factor the difference of perfect squares. Alright. 3 minus x is the same thing as, I can pull a negative out there, and that would be the same thing as x minus 3. So now I can, if I divide those, I get negative 1 over x plus 3. So therefore, 3 minus x over x squared minus 9 and negative 1 over x plus 3 are equivalent. And I'm going to come back here as long as x does not equal 3 and x does not equal negative 3. Okay? Because that's where it's going to be 0. Alright, last one. Go ahead and pull a 3 out of the top. So I have x minus y over factor y, and minus x and minus x. Alright. So I can switch this around. I'll pull a negative out, which will give me y minus x. Alright, if I divide one of those, I end up with negative 3 over y minus x. Alright. So I know that 3x plus or minus 3y over y squared minus 2xy plus x squared and negative, and I'm going to write it this way, 3 over y minus x are equivalent as long as, okay, and so here, since I don't have any value, any numbers there, I know that y cannot equal x. Because if y is equal to x, then we're going to end up with zeros. Okay? Alright, guys, hopefully this wasn't too bad, and have a great rest of the week.